Here is our setup, where we have demonstrated our technology Limeloop and our carbon capture heat battery. The gray box you see here is the furnace that provides the heat to offset the potential heat losses to ambient and maintain the temperature for the carbonation reactions. The furnace will also be used to do the calcination reactions at 850 degrees C. It is entirely operated by electricity, and you can see that its current temperature is 683 degrees C based on the thermocouple measurements. The Limeloop are placed in the reactor tube inside the furnace. The Teflon tube you see here is the gas inlet where diluted CO2 enters the reactor during the carbonation reaction shown here, or pure nitrogen for the calcination reaction. Carbonation was performed for about 10 minutes with 17% CO2 diluted in nitrogen, whereas calcination was performed in a pure nitrogen atmosphere with a flow rate of 1.7 liter per minute for about 5 minutes. When CO2 gets in contact with Limeloop, it gets trapped while the remaining components of the gas are allowed to pass through. From the top of the reactor shown here, CO2-free gas will exit. You can see from the graph, the outlet gas during carbonation maintains very low CO2 concentration for a longer period, compared with the blank test results showing how Limeloop captures a portion of CO2 from the incoming gases before it's fully saturated, at which the outlet gas concentration rises to 17%, equal to the inlet gas CO2 concentration. Here you see a set of valves and controllers are used to control the flow of gases into the furnace. Different CO2 concentration can basically be supplied to the reactor by mixing nitrogen with CO2. The flows are controlled through an automatic computer program, as you can see here. The outlet gas from the top of the reactor is directed to a gas analyzer where the gas composition is quantified and CO2 capture efficiency and Limeloop performance are measured. Now let's talk about the results that have been published in Chemical Engineering Journal and accessible to review. First, Limeloop performance is demonstrated in a fixed bed reactor for up to 5 cycles under relevant environment and conditions, increasing TRL to 5. Fixed bed reactor results also showcased similar trends to the analysis carried out in our TGA analysis for both natural sorbent and Limeloop, indicating Limeloop's higher CO2 uptake and stability. This was also a demonstration of our carbon capture heat battery. The configuration uses electricity in the calcination reaction at 850 degrees C under pure nitrogen to regenerate Limeloop. In principle, we are storing electricity as chemical energy by calcining our sorbent Limeloop. Next, we regenerate the stored electricity as high temperature heat during the carbonation reactions. When we expose Limeloop to CO2, we can see that the temperature of the gases leaving the reactor increases to 712 degrees C as shown in the results. This has demonstrated the concept of our carbon capture heat battery as we achieve TRL4. If you'd like to learn more about our solution, head to our website at www.remediumenergy.com or contact us at omid@remediumenergy.com. Thank you.